Let's discuss the third question in the networks section of the 2021 paper. Question 3 says the network diagram below shows the local road network of town M. The number of edges on the edges indicate the maximum number of vehicles per hour that can travel along each road in this network. The arrow represents the direction of travel, and the vertices A, B, C, D, E represents the intersection of the roads. Determine the maximum number of vehicles that can travel from the entrance to the exit per hour. Now, if you can see, the road that takes you from the entrance to A, the intersection A, can actually accommodate 1,500 vehicles. The first thing we do is we cancel all those roads that have a backward flow. So that's that one. So we go back to looking at, so 1,500 can either go along this road or along this one. So if 700 did go along this way, so we say 700 moved in that direction, leaving you with 800 that can go along here. So 700 out of 700, so this maximum capacity can be reached here up to point B, but the next road can only accommodate 680. So those 700 can reach the intersection B, only 680 can go through. And so 680 reaches the intersection at point C. Now, if 800 can take off from intersection A, it's only 650 that can go through this particular edge and reaches here. But there are two roads that take off from intersection D. What we have to do now is to look at inflow, outflow. The outflow from intersection C is the addition of these two values, and that is 940. So which implies that the inflow to this intersection, can be equal to 940. So which means 940 take away 680 that's already reached here is 260 more that can flow towards intersection C. So let's say it's coming in this direction, which means we take 260 out of 300 getting through to intersection C. Now that 260 is obviously going to come from the 650. So if we take away 260 from 650, that leaves me with 390 that can continue in this direction. And of course the capacity is 740, so 390 can easily be accommodated in that direction. And so 390 reaches here. So we can see that at the intersection E, there are actually two inflows. One is 320 and the other one is 390. The addition of these two inflows is 710. So 710 continues to flow towards intersection F. Is that possible? Yes, because its capacity is 840. So 710 is flowing. Actually, I say flowing, but it's actually vehicles moving. So 710 vehicles reach this intersection at F. But we see that at F, the inflow is along two edges. One of these edges carries a maximum of 620. So the inflow at intersection F is 620 plus 710, which is 1330. Now, is it possible for 1330 to move through this particular edge? Yes, because its capacity is 1500. So 1330 vehicles reach the exit of town M, which is the maximum number of vehicles that can travel from the entrance to the exit per hour. Now, the local council plans to increase the number of vehicles per hour that can travel from the entrance to the exit by increasing the capacity of only one road. Complete the following sentence by filling in the boxes provided. So the road that should have the capacity increased from vertex blank to vertex blank. Now let's look at the diagram carefully. We can see that we could still have accommodated a few more vehicles at this exit edge, and so 1500 minus 1330 is 170. Now, is it possible for any edges to have a balance which could have accommodated more? Now, clearly, along this edge, only 650 of 800 flowed through. Okay? So that left you with 150 remaining. Now, would it have been possible to increase the value of one edge such that that 150 could have also gone through? If we look at all the edges that had a balance, they were this one, because only 390 out of 740 went through, and then 710 out of 840 went through here. Now, if either of these two edges could be increased, let's see by how much this could have been increased. 840 take away 710 is 130. Okay, so if we had if this had reached maximum capacity of 840, we would have had to increase some edge by 130, and that would have increased this to by 130 and increase the capacity going to the exit. So is it possible for that 130 to have passed through the previous edge as well? So if we had added 130 here to 390 that came through, that would have given us 520. And that would have been possible because 740 was the maximum capacity. So 520 vehicles out of a capacity of 740 could have passed through. If that was to be the case, okay, that implies that this edge, if it had been 650 plus 130, 780, then we could have accommodated another 130 more that could have increased the capacity, minimum capacity of this road to maximize the flow of vehicles from entrance to exit. So, which implies that the edge that should have been initially increased is A to D. If its capacity had been 780 instead, with an increase of 130, okay, that would have allowed another 130 to pass through here, another 130 to pass through this one to reach maximum capacity, and that would have increased the number of vehicles reaching town M by another 130. So the road that should have its capacity increased is A to D. And what should the minimum capacity of this road be to maximize the flow? It should have been 780, which is 650 plus 130. Okay, so if you were to see the flow entrance, 800 from to A and to D, that was 780 of 780, and the remaining 520 could have gone through here to point E, and the inflow here is 520 plus 320, which is 840, which could have gone through here to F, where the inflow is another 620, and so the inflow at this point would be 620 plus 840, which is 1460, which could have also gone through here because its capacity is 1500 to the exit. Thank you.